Hello and welcome to this video. Today you're gonna learn how to build rugs with PostgreSQL. We're gonna use pgvector. First of all, we're gonna set this database locally. We're gonna connect to it. We're gonna build the rug locally. Then we're gonna go to AWS RDS, set the database over there so you can use it locally, but also you can use it in production environments. And if you haven't watched our previous videos on these topics, there are different videos on how to build your first rug locally, how to build your first AI agent, and also we built like a lead generation AI chatbot that is also sitting on the website and saving leads. And this video is kind of a continuation of the other videos, but previously what happened is we used ChromaDB locally. Today we're gonna use PostgreSQL DB, and we also set it up in production. So by the end of this beginner tutorial, you'll be able to learn how to build knowledge base from PDFs, store your vectors on PostgreSQL, and set up a database in production on AWS. And by the way, if you don't know me, my name is Jonathan, and I've been building software for the last 10 plus years since I was 13 years old. And now my focus is on building AI agents, and I share all my learnings on this channel. So check it out and subscribe and like. Previously, we used ChromaDB. ChromaDB is great, it's a dedicated vector store. You can also use it in production. The reason why I like Postgres is, first of all, I already used it previously to build my own SaaS applications, so I have an experience with it. But also, it's a powerful free database that is open source. It means that, and the community is very active. They always add new plugins, new stuff, and it's open source. It's similar to MySQL, but it's open source, and so they always keep improving it. The second thing is, when you use PostgreSQL, you can also use it for rational databases. So let's say you create like an AI agent or chatbot or something. Yes, you want vector stores, you want to build a rug, but you also want to maybe handle users and do some other stuff, which if you're using ChromaDB only, you'll then need another relational database, right? Now, recently the company Timescale, they released another extension, pgvector scale, that allows us to upgrade our PostgreSQL and get to the performance of the dedicated vector stores. So if I'll take a look at this chart, they are comparing between Pinecone, PostgreSQL, and pgvector. So without pgvector scale, we see here that Pinecone is way more faster and it's way better. But here we see something different, and we see that it's exceeding the performance here when using pgvector scale. So we are not going to talk about pgvector scale, but just know that at some point, if you want to enhance capabilities, if you want to make it more efficient, there is option to do it with Postgres as well, which is pretty cool. Now, the skills that we are going to talk about, the technologies that we're going to learn is Python, LangChain, Pydentic AI, PostgreSQL, Docker, and AWS RDS. And previously on the channel, we did a video on how to build your first rug, how to build your first chatbot and save leads to a CRM, and how to deploy your AI agent to AWS. Make sure you watch these other videos because it will help you understand what we are doing here. So just a quick reminder on what is a rug and what we are doing here. So essentially, we have a document. It's maybe a document about a business, a PDF or something. We decide on the strategy on how to chunk it, how to divide it to parts, because we don't want to get the whole document, we just want the relevant context. So we divide it to parts. We then use an embedding function to turn it into numbers, which is this process. So we take the text from our document, we embed it with the embedding model, and we get a vector. These vectors, we need to store them somewhere, and for this we need a dedicated vector store. PostgreSQL is a relational database that you can store like simple tables like ID, username, and all these things, but you could not store vector stores until pgvector plugin came in. Then now you can also store vector stores. Then what happens is, for the case of building a rug, we have a user query. We also embed it, turn it into numbers, and then we take the vector store, our vectors that we stored initially, we take the user query, we compare them and find the similarity or the distance in terms of meaning and context, who are the closest, and we get the result back to the user, right? And that's what we also gonna do today. I explain it very quickly for a purpose because we already done these parts in other videos, so make sure to watch how to build your first rug video, it explaining everything there in much detail. Okay, so let's get started building this thing. The first thing, I created a repository with all the details that you need to know. All you need to do is you need to clone it, get to the folder, create your virtual environment, activate it, install the dependencies in the requirements.txt. And also we have this file environment sample. It already contains all the details about the database. I'll talk about it in a moment, but you also need to put your API from OpenAI. Next, we need to set up our database. To do this, we need to set up a local database. So how do we do this? You need to install Docker because we're gonna launch it using a Docker image. And this is the settings that we are gonna use. So for this case, we're gonna set a database with the username Postgres, the password, and the database Postgres. The port is gonna be 5433, and we're gonna use Postgres 14 version. Okay, you can feel free to change all these parameters as you wish, but then you will need also to change other things, and we'll talk about it in a moment. So I'm gonna run it on my machine. And now we see that we got this container. We'll take a look at the one that's running right now. So we'll take a look. If we go to the execution and we just want to test it, it's actually working. We'll go here, we'll paste this, and now we see that we connected to our Postgres local database. If we are not using LangChain, which in this video we do, it's doing all the setup for the PostgreSQL database behind the scenes. But if you are not using that, what you'll need to do is you need to activate the extension of pgvector. So you'll go, you connect to the database locally, and then you will need to run this command to make it work. And you will also need to create a table dedicated to storing your documents or embedding. We'll see in a moment what I mean. Now, to verify that it's actually working, let's connect to it locally. I'm using pgadmin, which is not so comfortable, but you can use your own. All you need to do is you need to register server. I'm gonna put here local DB, local host 53, and the password is gonna be password, and you're just gonna do save. And this is how we know that it's working. And if we'll take a look at the database itself, we see that we have no tables and it's empty. Now, to build our database and to set it up, you don't have to do this step, but just for verification, this is what we're doing here. So the pgvector instance is giving us an instance of this database, which will allow us to write, read, update, whatever we want. We kind of use the singleton pattern here because we want to initialize it just one time, and that's it. And we take the information to connect to it from our settings. So the settings is a pretty cool utility that is using Pydentic settings, and here we have all the settings of the application. I set it up here, all the information about the database, and this is the database URI, and you just need to use the structure. Now, what's cool about Pydentic AI settings is once I do load.env, and if I use the same parameters as in our .environment file, it will automatically load them. These are default values, but what happens is it takes them from this file. So if you want to change the settings of your database, you can just add it here, and we'll do it in a moment once we set up the AWS RDS in production. But that's all we have. Once we run this just for checking, gonna do, let's say, just call this get. So yeah, so what's happening here is we get the database URI. This is what allows us to connect to the database. We then give it a collection name. This is where all our embeddings will be stored. And we also give it an embedding function. This is the embedding model that we talked about in the chart. And every time that we get new documents to this DB instance, it's gonna use the embedding function, turn it into numbers, and store it in our database. The first time we run this, because we are using, this is a LangChain utility, and in the background, once we initialize it once, it's just gonna set all the database for us. So if I copy this command and run it here, we see that it loaded a little bit and nothing happened. But if we go back to our database, we do refresh, then we see here two new tables. The first one is the collection that we created, and the name is documents. And the second one is where actually the embeddings are gonna be stored. We have ID, we have collection ID, we have the embedding, the vector itself, we have a document, and we have metadata. Now, if you're not using LangChain and we use something different, you'll need to set some of this manually. There is cons and pros to do this, but for the simplicity of this video, we use LangChain. Now that we have a set database, we need to store our vectors and to build this kind of vector store, right? So I created this file build vector db. So if you watch the how to build your first RAG video where we built a RAG we used ChromaDB as the database to store the vectors, this logic here is pretty much the same. We are loading the documents from the docs folder. So each document that you put here is just gonna be inserted into the vector database. We are chunking them. Here we added something different that we didn't do in the other video, but it's not really necessary unless you wanna store UIDs. Then what we are doing is we are updating the database. The The logic is pretty much the same because we are using LangChain. So LangChain is wrapping everything around our databases. Even when we are using Chroma, although here we get pgvector, when we did ChromaDB, we got ChromaDB instance here or object. They also had this function get by IDs. So the logic is pretty much the same because we are using the encapsulation, the classes from LangChain. And the basic logic here is that chunking, doing all the process, we are checking if it's already in the database. We don't want to get it inside the database. If it's already in the database, but it was changed, we want to update it. Okay, so this is all the logic of the update database here. And of course, if you are not using LangChain, this is one of the cons or benefits of using LangChain is that they do everything for you, so you don't need to manually set this up. On the other end, if you want to customize it for your cases, or maybe you have something specific you want to do, you will need to do it yourself. And again, if you want to watch in detail on what actually we are doing here, you can go and you can watch the other video of how to build your first drug, because this video is more focused about the integration with Postgres. So we're going to take this command, we're going to run it, and now we see a lot of cool stuff here. So first of all, we see the hash, we see the ID. This is the string ID. We see that the database was initialized successfully. If we go here and we click play, we see that we now have an embeddings. So this ID, and you also see it in the logic, I took the same string ID that we generated on the previous video, and I just turned it into UUID. You don't really need to have it, but it's just something I added here. And now we see the cool part is that we see the numbers actually that generated from the document. So we see the embedding here, but we also, if we'll scroll to the end, we see the metadata, which we have the hash, we have the page, we have the index, we have the source, and we also can see the documents themselves. So this is the chunks, this is the embeddings of these chunks. So we have everything on one database, which is pretty cool. We now have the database. Now let's check if we can query that. And let's take a look. So we have this part of the vector store. We now wanna take the user query, embed it as well, find the most relevant documents, with the LLM, give back an answer. So let's take a look how it's done. In this file query rug, we are using Pydentic AI, which is a pretty cool new library for building agents, and it's more lightweight and I like it better than LangChain, and they keep adding new stuff, which is pretty cool, but you can check it out later. So this function is, all it does, it's again, we are using the pgvector instance. This is why it's, by the way, a singleton, because we have a few areas that we are using this instance. So then we are performing similarity search with score, and we get 3 documents. We print it out like the documents that we got from querying RDB, and we also get the score of how much they were similar. Then we build like this pretty simple AI workflow. We just tell the AI, okay, answer the question based on this context. The context is the documents that we got from the vector store. We send the question. We are using GPT-4o for this, query this, and give it 0 temperature. We just print the usage for myself just to see how many tokens it took, and we'll return the response. And to run this, go here. And we see a few things here. So first of all, it's printing the document. So this is the score of the first document, 0.219. This is the score of the second one. This is the score of the third one. The response was, to fix a pipe, you would likely need to use routine repairs, which starts at $80. And if I take a look quickly at the document, we see routine plumbing repairs. Let's see what's the pricing. So we see that it's $80 per hour. Pretty cool. So far what we did is we have a local database in Postgres that is able to store vectors, and we can also query that. Now the question is how we get this into a production environment, and not just on our local machine, but also remotely. So let's do that. Okay, so for this video, we're gonna see how to use AWS RDS. If you want to use other providers, obviously you need to follow other steps. You're gonna go to the console in AWS, you're gonna write RDS, and you're gonna get to this. Let's create a new database, and we're gonna pick Postgres, and for the setup you pick free tier. Now if we scroll down, you see the pricing here, the estimated monthly costs, and we see that it's free if you are in the free tier. If we change this, for example, to dev or even production, we see different numbers and different costs. Now we see that we have like a 200 plus bill, right? So I'm not sure how AWS defines like production or development or whatever it is, but when you pick the free tier, you also have the ability to pick lower tier instances like these ones, and you can also upgrade it later. So if we pick the production one, you see that we can only choose from the expensive instances. So we're gonna pick free tier. Let's here give it the version 14. This is gonna be our identifier inside of AWS. This is gonna be the master username. We're gonna do auto-generate password. We're gonna keep this instance for now, 20 gigas. And here we're gonna do public access. Now, a few words about this. In real life applications, what people do or startups do is that you have a VPC that is private. Maybe you connect to it by VPN. Locally, you can connect to a VPN that connects to this VPC, and then you have access to this database. What it does, it's adding a layer of security, because if we put it public, once someone has the password to our database, they can get in. So the best practice is usually to have like a VPC that is private and the database is also private, and developers or whoever it is accessing the VPN that accessing the VPC, and also the applications or servers, the EC2s, whatever it is that are accessing this database will also have access to this VPC, so they can also access it as well. And this is what usually people do. So for the rest of the settings, we're gonna keep it same, and we're just gonna go here and you're gonna give the name of the database, let's say testdb. These ones we are gonna keep it and create database. Now, while we wait for this to be created, I just wanna mention that this is an educational video, and when you are in production, do your own research. You need to check what things that you need, and this is just to show you like some of the steps, but by no means don't use it in production environment unless you do some research. Okay, a few moments later, and we have the database ready. We're gonna click on the view connection details, and we're gonna see the password there. If you set up your master password yourself, then you don't need to do this, but we copy the endpoint. What you're gonna do is you're gonna go to your environment file, and you're gonna put this in the host, put the password in the password, and the database testdb. First of all, let's test it with pgadmin, see what's up. So I'm going here. Again, register server, let's say AWS, YouTube, connection, copy the host. In the database, we put testdb, in the password, master password, save. Okay, great. Now we are connected to our database. Now, one thing to notice that I got stuck on while recording this is if you cannot connect to your database, it's because you need to update your security group. So what you're gonna do is you're gonna go and edit your security group, and in your inbound rules, just add here new rule, and you do custom TCP, put the port, put here this one, and just add it. And I already have it here, so that's how I can connect to it. So now we have the database. If we'll take a look, we have here the Postgres database that we can also connect to. We have the one that we created. If we'll take a look at the tables, there is nothing here. Now we want to do the same process we did locally, just on our remote machine. So here we need to change the port, this one. Then we have all the information in here. We again run this command, which we actually don't need to run. I just want to show you this in a step-by-step approach. Now we see that it's finished. All you need to do is just call this one and it will already do everything. But just to illustrate this, so we do refresh. We see again the same things that we had before. If we build our DB again, we now see that it's fully initialized. If we see the vectors themselves, so these are the same vectors that we got locally. And now if we query this rug, and we got the same answer as we got locally. So that's it. We've seen in this video how we set up a local PostgreSDB database with Docker, then how we populate this database with our documents, with our PDF, then how we can query this locally, then we set up on AWS RDS and connected to a production environment database. And that's it for this video. Thank you for watching this video. If you like to see more videos about AI agents and the in-between, click the like and subscribe. Also, I keep updating these videos and adding new knowledge to this channel, so make sure to subscribe. And if you want to learn more how to apply this to your use case, these videos are very generalized, and maybe you have a specific use case, maybe you want to know what are the best technologies to build for your use case, we can connect on LinkedIn. You can send me a message on LinkedIn and I can just guide you through this. Again, thank you for watching, and I'm sure you're gonna like this next video right here and the other video right here, so make sure to watch them next. Thank you for watching. See you in the next time. Bye.